Hello everyone, in this lecture we are going to learn about attachment details of flathead 2 shell corner welded joints. Our flagship courses are Master Static Equipment Design and PVElite, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs, so do visit our learning platform for more details on scootoid.thinkific.com.
Now, corner welded, corner joints, this may happen when we have shell and flathead directly getting welded. So if I have only this groove weld, whether that is sufficient for this kind of corner joint, whether having only groove, okay, is sufficient for this kind of joint. It should have groove plus fillet like we have indicated. Okay, so we should always have a joint like this. Okay, here you have two terms. One is A, B is not seen here. I'll just add one more figure there. You'll be able to see even what is B. Okay, so B is actually the depth. Okay, you can see here B. It is how much cut you are having in this, in the flathead, how much thickness you are machining to make the groove. That is your B, and this is A. So A plus B should be always greater than 2 times of the shell thickness, twice of the shell thickness. So A plus B greater or equal to 2 times of the shell thickness. Clear? So that is very much required. Typically, you always have this kind of joint. So please remember this. Okay. Now here, if I'm having TW, that should be always greater or equal to TS. So making sure that you are having complete penetration. Okay. So it should be always greater than that. So that means I need to even have a fillet weld. Okay. Because A is required. Otherwise, I won't be able to achieve this. Only A is there. Then also it should be greater than 2 times of shell. How I'll get that? Only when I have a fillet weld also of the same length, okay, of the TS length. Okay, so that is the requirement related to a corner joint. Okay, now moving further. Okay, similar thing here also. Here you can see that A and B both are required. So both should be greater than 2 times TS. Okay, that is the requirement. Okay. Now here there is one more term coming, which is TP, which is the remaining thickness of the flathead. Okay, so that should be always greater than TS shell thickness. It should not reduce whatever groove I'm making. It should not reduce to lower than the shell thickness. Okay, or the second value is 6 mm. So you have to compare whatever fillet getting mentioned here is 0.7 times of TS shell thickness. Okay, great. That is the minimum value. Okay, now you can also have this kind of weld when you can use a backing strip. Okay, so that you can achieve a full penetration at this corner. Okay, to achieve a full penetration at this corner, I can have this kind of joint also where fillet weld is outside, okay, instead of being inside. So that is also possible, and the same condition will apply. A plus B should be greater than 2 times TS. So whatever configuration we saw, what is the takeaway for you as A, which is the total length of the groove or the fillet. B is the depth. Okay, if any machining we are doing in the flathead. So both combined together should be more than twice of the shell thickness. That is the takeaway we should remember. Okay. Now next, even I can have this kind of weld. It is permitted. Okay, having both fillet weld, both side fillet weld. But these kind of welds are always given when we have a proper support. Okay, so if I have this, then what are the conditions given? A1 plus A2 should be equal to A. Both combinedly we define as A. And then again the same requirement is given, A plus B should be greater. Here there is no B because there is no machining done on this flathead. So there is no B. B is 0 in this case. So A plus B should be greater than twice the shell thickness. Okay. One more requirement, your A1, whatever fillet weld you are giving, that should be always between half of A2. Okay. A2 is the weld which is inside. So inside weld should be always higher. Okay. So A1 can be lower. It will vary between half of A2 to 2A2. That is the range where it can vary. Okay. So this is the typical requirement related to fillet weld size 0.7 times TS. The minimum, this also we have to maintain. I can have larger value to meet this requirement. Okay. That is possible. Getting it? Great. Now what? Again, if I have a flange with bolting, anything will change? If I have a flange with bolting, again, same scenario. A and B are same. Only that C you see, that is the additional value you see here. And there is backing strip that we provide to achieve the full penetration. Okay. So again, A plus B should be greater than 2 times TS. That is the old requirement. C, which is the additional term here, that also should be greater or equal to 2S. So finally, what happens? Your mean strength taking zone for this weld is this much. Okay. This here, because the bending is what mainly tries to stress this point. So bending load is main load which is governing for any corner joint. Okay. So instead of apart from giving A plus B requirement, C is also mentioned. Okay, for these cases. Okay, great. Again, other cases also like B, the B can be even depth. If I have a depth, then B also will be introduced. Similar requirement for here also. Okay. If I'm having only fillet weld, then also I can provide similar fillet welds. Okay, like we saw in the flat. If there is no bolting, only that C is additional term, which is again greater or equal to 2 times of the shell thickness with which we are attaching. Okay. Apart from that, other requirements are exactly same what we have seen. Okay.
For in-depth training. And to learn more about these courses, register with the link in the description.